Hello all. So today we'll be seeing about superposition theorem. This theorem we are speaking about is from the concept of network analysis. So we'll go into the concept. Okay, so these are the topics we'll be discussing today. So we'll be seeing about what superposition theorem is and a proper definition for the theorem. Then how do we solve the superposition theorem solutions or questions based on superposition theorem, and we'll see an example about it. So let's go on. So superposition theorem speaks about having a network where we have more than one supply source or energy source. That is, it can either be number of voltage sources or a number of current source or a combination of both. Where if we have n number of these sources, then how do we calculate the amount of current or the voltage present in a separate element of a circuit? So that's what we're going to study over here. So let's see about the proper definition over it. This is what it is, a proper definition for the superposition theorem. Superposition theorem states the following. In any linear and bilateral network or circuit having multiple independent sources, the response of an element will be equal to the algebraic sum of the responses of that element by considering one source at a time. So as we said earlier also, so it considers of multiple sources in which we consider separately one separate source while we're calculating the voltage or the supply for a separate element. And then we add up all the values that is given for different sources. So that's what we do in superposition theorem. So let's see how we solve a question regarding to it. So how to solve. First step that we do in solving a superposition theorem solution is that we are going to consider one separate source. If you have, say, three sources, consider it's two voltage source and a current source. So first we can say that we'll take the current source and we'll neglect the voltage sources or consider it to be zero. Over here, when we're taking a current source, considering a current source and neglecting the voltage source, we'll have the voltage sources made short circuited. And when we're considering the voltage source and neglecting the current source or making the current source zero, we'll make the current source open circuited. So that's what we are doing over here. The first step is to select one among the multiple sources present in the bilateral network. Among the various sources in the circuit, any one of the source can be considered first. Like I said, you can either consider a voltage source or a current source. Just we have to consider one separate source at a time and then add up all the values that we've got for one separate source to get the overall voltage or the average voltage or the supply given for an element in the circuit. So that's what is spoken over here in all these points. If you want, you can just pause the video and read them. So we'll continue and see with an example problem. So the question says that find the current flowing through 20 ohm resistor of the following circuit using superposition theorem. So this is the circuit given, and you can see that over here you have a 20-volt voltage supply and a 4 ampere current supply. So let's say over here in this solution we've taken the voltage 20-volt voltage source and neglected the 4 ampere current source, or we've just taken it as zero. And as I said before, for current source, if you're going to take current source as zero, you make it as open circuited. So you can see over here there's no current source given because it's open circuited. You just have the voltage source. So now while solving this circuit over here, you can use different methods like loop analysis, node analysis, KVL, KCL, etc. Over here, let's try to solve this question using node analysis. Over here in node analysis, it means that you'll just consider a separate node. Let's say we'll consider this node over here and take it as V1 and solve to find the voltage or V1 over here. So see, we consider this as V1, and over here, this node, we consider it as earth node or base node. So see, here it's given there is only one principal node except ground node in the above circuit. So we can use the node analysis method. The node voltage V1 is labeled in the following figure. Here V1 is the voltage from node 1 with respect to ground. Over here, the thing that we're doing node analysis, it's same as the KCL that we apply, where we just have to take the base voltage and subtract it with the voltage given in that particular loop. And if you don't have any voltage in that loop or to that element, you just consider it as zero. So let's see how it's solved. Okay, over here you can see that you've taken the base node or the base voltage, V1 minus the voltage of that branch or that element, 20 volts, minus the resistor divided by the resistor, 5 ohms. So V1 minus 20 by 5 plus V1 minus 0, because there's this 10 ohm resistor over here that has no voltage supply or any other supply. So here it's 0 volts. So V1 minus 0 volts we get as V1 itself, divided by the resistor 10 ohms, plus V1 minus 0 volts, because over here also for this 10 ohm and 20 ohm we don't have any other voltage supply. So over here also it's 0, and it just becomes V1 divided by 10 plus 20, and the overall value, or the overall voltage is equal to 0. That is, when you sum up all the values of all these things, you have to get a 0 value for it. Any current leaving the node or reach entering into the node is equal. So when you just calculate it completely, the amount of voltage or the current present in the node is equal to 0. That's why we've taken it as 0 over here. Once we solve it, taking the LCM of all these denominators, we get it as 6V1 minus 120 plus 3V1 plus V1 divided by 30. And so the value of V1 is equal to 12 volts. And by Ohm's law, we know that V equals to IR. So I1 should be equal to V1 by R. So here we've taken I1 equals to V1 by R, that is 10 plus 20 ohm, because we have to find the current flowing through 20 ohm resistor. That can be found by doing the following simplification. So now substituting the value of V1 up in the above equation. So we got V1 as 12. So now I1 equals to 12 by 30, which is equals to 0.4 amperes. So this is what we found at the current value for the first case, or just considering 20 volt, and we found the current I1. So now let's see, while we're considering only the voltage, we are only considering the current source and neglecting the voltage source and making it 0. So this is what it is. So that's step 2 or case 2. So now we are finding the current value with respect to the current source and neglecting the voltage source and making it as mm, short circuited. So you can see over here that there is no voltage source, 20 ohm voltage source given over here. It's just a straight line, which means it's short circuited. And you can see that now we have the 4 ampere current source present over here. So now again solving it, and we can see over here that they've taken the equivalent resistance. In the above circuit, there are 3 resistors to the left of the terminal A and B. We can replace these resistors as a single equivalent resistor. Here 5 ohm and 10 ohm resistor are connected in parallel, and the entire combination is in series with the 10 ohm resistor. So here we have just calculated the equivalent resistance. That is, you can see over here that the 5 ohm resistor and 10 ohm resistor are in parallel with this 10 ohm are in series with this 10 ohm resistor, and these two are parallel to each other. So you can see over here that we've done the uh, calculations over here. So 5 into 10 divided by 5 plus 10 plus the 10 ohm resistor that is in series. And then whatever value you get over here, then that is what the simplified circuit, or the equivalent resistance for all these 3 resistors. We are not calculating the resistance for this one also, or including this in the equivalent resistance, because this is where we want to calculate the current or the supply for. So you don't add this into the 20 ohm resistor into the equation. See what that's what we've done over here. 40 by 3 is dead over here, and then the 20 ohm is not being considered. We just let it go that way itself. And now while we are going to calculate the current, we use the current division rule. So in this current division rule, it states that for the resistor which you want to find the value of current, you just consider that resistor, and you solve the equation by just adding up the values of these two resistors in the denominator. So you can see over here, that's I2. That's the current for your case 2, which is equal to the source current into a resistor 1. So the resistor 1 over here is the 40 by 3 ohm resistor, or the resistor that's being calculated as R equivalent. So divided by R1 plus R2. R2 is a 20 ohm resistor for which we want to find the value of current. So that's what we're substituting over here. See, it's given as Is equals to 4A, that's 4 amperes, R1 equals to 40 by 3 ohms, and R2 equals to 20 ohms, the above equation. So I2 equals to 4 into 40 by 3 divided by 40 by 3 plus 20. So you'll be getting it as 1.6 amperes. So that's current I2. And as I said before, that you'll be calculating the current separately for each sources, and then you'll sum them up to find the overall voltage or the current supply given for that particular element. So using that method or using that principle, you'll be adding up I1 and I2. So I1, we've seen that it was uh, we got it as 0 0.4 amperes, and I2 was 1.6 amperes. So now the overall current flowing through 20 ohm resistor is uh, 1.6, and only 4 ampere current source is considered. That's the current for I2. And now we'll see over here, as I said, I equals to I1 plus I2, or the current through 20 ohm resistor. You just add them up and you get a 0.4 plus 1.6, which is equals to 2 amperes. Therefore, the current flowing to 20 ohm resistor of the given circuit is 20 amperes. So this is all about superposition theorem. We've seen an example and about how to solve it. As I said before, um, we'll be using these theorems while you're solving any circuit that has more than one voltage source or more than one supply source, energy source or supply source in the circuit. And we solve it by taking a short circuited voltage source and an open circuited current source and then add them up. Over here, if you have any doubt with the calculations, you can also use other theorems and calculate it so that you can cross verify them also and find out whether your answer was right or not. So thank you. That is all about the superposition theorem.